Now we're going to take a look at interaction diagrams. Interaction diagrams show how objects interact with each other. There are two types of interaction diagrams: sequence diagrams and collaboration diagrams. In this video, we're going to look at sequence diagrams. The purpose of interaction diagrams is to visualize the interactive behavior of the system. Visualizing the interaction can be difficult, so the solution is to use at least two different types of models to capture the different aspects of the interaction. The first is sequence diagrams, second is collaboration. They both are used to capture the dynamic nature of the system from a different perspective. The purpose of interaction diagrams in general is, specifically, 1, to capture the dynamic behavior of a system, 2, to describe the message flow in the system, 3, to describe the structural organization of the objects, and 4, to describe the interaction among objects. The sequence diagram captures the time sequence of the message flow from one object to another. The collaboration diagram describes the organization of the objects in a system taking part in the message flow. They are related, but there are different views. That is, you can transpose a sequence diagram into a collaboration diagram and vice versa. There are a few things you need to do before you begin drawing the interaction diagram. 1, you need to identify the objects taking part in the interaction. 2, you need to identify the message flows among the objects. 3, you need to specify the sequence in which messages are flowing. And 4, you have to define the object orientation. Here's an example of a sequence diagram for an order management system. Note there are 4 objects: customer, order, special order, or normal order. This diagram shows the message sequence for the special order object, but it can be the same. You could substitute normal order for special order. It's important to understand the time sequence of message flows. They flow from the top to the bottom. Okay, this message goes first, this one goes second, this goes third, this goes fourth, top to bottom. Flow is nothing but a method call of an object. Let's take a look more closely. So the first call is send order. It's sent from customer to order. So this is a method of this object, the order object. The next call is confirm, which is a method of the special order object. The last call is dispatch, which is a method of the special order object. This is a self call. It's sending a message to call itself. And then we also have return and return. Note these are called the lifetime of the activation. This is when this lifeline, the dotted lines going down from the objects are lifelines. The little rectangular area is when the lifeline is activated. This one's a little simpler, and it doesn't have as much notation. Actually, more notation is better. You want it to be rich. And so the caller picks up the phone returns the dial tone to the caller starts to dial. This is an old chart. Then the phone sends out methods in two directions. 1, a ring to the recipient, and 2, a ring notification to the caller. The recipient then picks it up, that sends that message back to phone, and then the recipient talks, says hello back to the caller. Sequence diagram shows object interaction. Here's some more specialized notation that you can have. A and B are objects. A looping method message being sent back to itself is called a self call. You can have both synchronous call. Synchronous, it has 2 arrowheads. Asynchronous, it only has 1 part of the arrowhead. You can have transmission delayed. This is very rarely used. Plus, you can have conditions and iterations, where in order for a method to be fired, some condition must evaluate to true. And you can also have iterations, which means it repeats over and over again for some condition to be true. This demonstrates just a few additional features. Objects can all be in existence at the beginning when you initialize the sequence diagram, or you can create objects as you go along, as we do here. We create B with a create message. A sends a message to create B. The lifeline starts when the object is created. Here's A's lifeline, the dotted line. Here's B's lifeline, dotted line. It's symbolized by the rectangular stripes. You place on the lifeline where the object is activated. The rectangle shows where the object is active, that is, sending or receiving calls. This object A exists from here down to here. Remember, the time phase is this. Time goes downwards. As time goes along, you go down the lifeline. But A is only active in this rectangular strip. B is only active in this rectangular strip. B, unlike A, B gets deleted at this point in time right here, and it no longer has a lifeline. You designate that with an X. So here's one more example of a sequence diagram demonstrating the behavior of objects in a use case by describing the objects and the messages they pass. Okay, so here's user's lifeline. The rectangle is when it's active. It sends a message to look up to catalog. Catalog sends a message back. And we're numbering them here in the order in which they occur. 1, 2, 3, 4, 5. 5. These two evidently can occur together. 6, and these two occur together. Okay. So horizontal are objects participating in the interaction. Vertical is order or time. This is beginning, this is end.